In this question we've got the function f of x equals e to the x and g of x equals sine x. So a composite function is when you substitute one function into another function. So in this case we have h of x, which is f of g of x. So when we are doing that, so here f of g of x, so we know that f of x is e to the power x rather, and then we're doing f of g of x being sine x. So essentially what we're doing here is wherever we see the x, we're going to replace it with sine x. So this will be e to the sine x. Therefore our function here, h of x, is going to be e to the sine x. So the next two questions here, stating the domain and the range, we can look at the graph. So I'll just go into this in quite a bit of detail. So first of all, what I'm going to do is I'm going to sketch the graphs of both of them, and that will help me get the domain and range of both functions. So first we'll draw f of x equals e to the power x. So we've got an exponential with no transformation, so it's going to look like this. And then we have f g of x. So g of x equals sine x here. So we'll just draw a couple cycles here to that. So we know it's going up to 1, negative 1. So thinking about the domain and range of both the functions here, we know that the domain of f, so we can do a domain and range table here. So let's think about the domain and the range of both the functions here. So the domain of f, we can see, is going to be r, okay, which doesn't tell us in the question. And the domain of g is also going to be all real numbers. The range of f here is going to be 0 to infinity, not including. Or you could write r plus there. And the range for the sine graph is going to be going from -1 to 1. So therefore we can look at what our domain and range is. So h of x is the composite function, f of g of x. So we'll just look at how that actually works. So when we're forming a composite function, I'm going to start off with x here. And when we're performing this function here, we want f of g of x. So the function that you're going to perform first is going to be g, and then you're going to perform the function f on that, which will give you f of g of x. So thinking about how this starts, what you're going to just look at the first part of the function here, the g part. So when we do that, we're going to start off with the domain of g. And when you do that, what you're going to get out is the range of g. If we look at the second part of the function, the second part of the function is f. So therefore we're going to start with the domain of f. And this is going to be the key here. And then what we always get out is going to be the range of the composite function. So if this function exists, which we will see if it does exist, then the domain of f of g of x, you see, is just going to be the domain of g. So it's always the domain of the inside segment of the composite function. So in this case, you see here, we're going to start off with g. So the domain of g, you'll see here, is r. The range of g is -1 to 1. And the domain of f is all real numbers. Okay, so that's all we can see so far. Now, if we look here to see whether it actually exists, then if we're looking at the values that we're getting out here, -1 to 1, are there any values there that are going to stop the second part, f, of the function working? Now, f works for all real numbers, so there's no values that you're getting out here for the range of g that are not going to fit in the domain of f. Therefore, the function is going to exist. Okay, so what we can say here is it does exist. It's not asking us this, but we can say the range of g is a subset, lies within the domain of f. There's no values that we're getting here that will not work in the second part of the function. So therefore, because it does exist, we can see that the domain of h of f, or h of x rather, is going to equal the domain of g of x, which is going to be all real numbers, because that's what we start off with here. Okay, so to look at the range now, so the range is a little bit more complicated, so it's not, I mean, sometimes it will just be the range of f, that's going to be the case, but in this case that's not going to happen. So the way we need to think about this to get the range, a useful way is to use the graphs. So you'll see here, these are the answers that we're getting out here. So minus 1 to 1. So these are the only answers that you're getting out after the first part of the composite function, minus 1 to 1. So therefore, this part then is no longer going to be in the domain of f. The domain of f is only going to be the values that you're getting out from the range of g here. So your domain of f is actually going to become minus 1 to 1 for the second part. So what we can do is look at the graph for f, which is here, and this is only going to exist. The domain of this is going to be between minus 1 and 1. So this value here is going to be minus 1 something, and this value here is going to be 1 something. So if we sub these values in, you see, it's going to be e to the negative 1, and this one here will be e to the 1. So therefore, this is the only section that it's going to work for when we're doing the second part of the composite function. So that means that the range of this function, you see, is going to be from, so if we do the range of h of x, that's going to be from e to the negative 1, including, to e, which I would prefer to write as 1 over e. Okay, because it's just important that we understand that because the range of g, these are the values that you're getting out, so they're the values that you're going to substitute into the second part of the composite function, which is f. So your domain of f is going to become minus 1 to 1. And if we look at that, that's what's going to exist. And then the range, we can get the range from that. So if we look at that using CAS, we can make sure that we get all of this right. Alright, so if I define f of x here, so f of x was e to the x, so we can define that. So e to the x, so we can just check our answers. G of x was this. Okay, so sine x. Okay, and then I can define h of x. So h of x being the composite function f of g of x, so we can just type in f of g of x. So we can check our answer to the first one, so it's e to sine x, that's what we got. We can say what the domain is going to be, so you can either type domain or go into the book, number 1. So if it's not shown there, you press D and then scroll down to domain. And then you'll see here it says domain and then expression, variable. So the expression is h of x, the variable is x. So you put that and you see all real numbers, that's what we got. And to get the range, you have to do it graphically. So if we just plot the graph, see what it looks like. So we do h of x, this is the graph here. And if I want to check these values here, we can do, so basically find the f max, f min here, but because it's a circular function, I'm going to have to restrict the domain. So if I say f min of h of x, and then I need to restrict the domain here. So if you look at the graph, you've got a minimum here between what, 1, 2, 3, 4, and 6. So I can just restrict it between there. So let's go 4, less than x, so there. So you'll see here that you've got 3 pi on 2. So if you substitute that in, so h of 3 pi on 2, you see here, that's the lowest value to negative 1 like we got. And then we'll do f max. I can just change this. So do f max h of x. So let's just see where the maximum, one of the maximums is anyway. So between 1 and 3. So just change this to 1 and 3. That will give me pi on 2, and then let's do h of pi on 2. And that'll give us e, so we have got it right. Well done.